Okay, we're finding the vertex of a quadratic function. And we've got three forms here. We've got vertex form. Seems like a good form to find the vertex from. We've got standard form here. And we're also vertex from factored form. So say we had something like x plus 2, x minus 6. So this is factored form. Okay, so we're going to review how to find the vertex of a quadratic function. So remember, the vertex is going to be our max or our minimum value in our function. So if we want to find a given vertex form, it's pretty easy because the vertex is already isolated kind of. So these two values will give us our vertex. So the vertex of this is -1, -5. And we also know that this vertex would give us a minimum value, because since A is positive, we can tell the parabola is going to open up and the vertex will be at a minimum. So our minimum value would be -5 when x is -1. Okay, if we want to find the vertex from standard form, we got a couple different routes. So we can do what you learned in grade 10, which was we can complete the square to try to find the vertex. So when we complete here, we want to make it look like this vertex form here that we have. So we're going to factor a from the first two terms, leaving us with x squared plus 6x in the brackets. Next, we're going to turn the bracket into a perfect square trinomial. So I'm actually going to add a 9 here because I know this will make a square. And to figure out what number you need to add, you can take this middle term, divide it by 2, get 3, then square it. That method will work every time for making this into a perfect square. But I can't just add a random 9, so I'm also going to subtract it, because I don't want to change my equation. Okay, but I just want the perfect square. So I'm going to move that negative 9 out of the brackets, but when I do that, I need to multiply it by 2 to get it out. So I got x squared plus 6x plus 9. And when I move this negative 9 out, I multiply it by 2, so it becomes -18. Okay, final step, I'm going to factor this perfect square trinomial for two numbers that multiply to 9 and add to 6. And I know they're going to be the same two numbers because it's a perfect square trinomial. So it's going to factor into x plus 3 times x plus 3, which I'm going to write as x plus 3 squared. And then I'll simplify that to -21. So I know I have a vertex at -3, -21. So I just change standard form into vertex. So another thing I can do is if I don't want to complete the square, I can also do partial factoring, as we taught you yesterday. Partial factoring is when we use our parabola is symmetrical. So whatever this value is, we actually set y equal to that. And what I'm doing here is I'm going to try to figure out, I don't know what this parabola looks like, but when y is equal to -3, I don't know what my two x values are. Okay, so I have everything goes to one side, so I'm going to -3 plus 3 would be 0, so I'm just left with this. And 0, and x equals -6. So what I've just done here is I've just found out that when y is -3, I have an x value at 0 and an x value at -6. And then my parabola looks like this. So I'm trying to find the vertex. So one thing I know is the vertex may be right in between those two x values. So I know my axis of symmetry will be at x equals -3, which is also the x value of my vertex. So to find the y value, I'm just going to sub the -3 in for x. And then I solve y is equal to negative 21, just like I did in the other question. So I know my vertex is -3, -21. Okay, and finally, solving from factored form is actually really similar to partial factoring. So we're actually just going to find our roots by setting y equal to 0. And then I set each bracket equal to 0, which leaves me with x equals -2 and x equals 6. So those are my roots. So I know my axis of symmetry is going to be right in between those, which will be at 2. And then now I just need to set that back into my equation to find the y value of the vertex. So I get 4 times -4, which is -16. So I know my vertex will be at 2, -16. So there's actually 4 different ways you can find the vertex given any form that you're given. Of course, you're always welcome to expand factored form into standard form and then put it into vertex form. There's like multiple ways you can do this. But that would be how you find the vertex. And this comes in handy when you're doing word problems that involve things that say like find the maximum profit or find the maximum or minimum something.